are Team 262 participating in Texas Instruments Innovation Challenge 2015.
Project is FMCW radar for automotive imaging.
The aim of this project is to provide driver assistance using a radar during low visibility conditions. The reason why we are doing this project is because India has one of the most challenging roads, and most of the accidents are caused due to low visibility conditions, which could have been easily avoided. So we are providing a low-cost radar solution to the masses, which now is only currently available to the high-end supercars. The project is a radar which is mounted on the car. The radar is mounted on a stepper motor which continuously scans to provide maximum aperture. We expect a maximum of 50 meters range in all conditions, fog or rain.
We have three subsystems: the radar front end, the analog front end, and the signal processing subsystem. We have a auxiliary onboard diagnostic subsystem which reads real-time car parameters. We have antennas as our antennas. The transmitting antenna transmits a S-band signal which impinges on an object and is reflected back to the receiving antenna. Both the signals are mixed at the microwave stage and is processed at the analog subsystem. We have also developed a low-cost system which costs less than 1,000 rupees.
The microwave intermediate frequency signals are passed to the analog front end. We have developed a prototype solution for this earlier. Here is the product solution. The analog front end board comprises of OPA 1612 audio amplifiers, which form a 6th order low pass filter. The gain of the filters is controlled by the TPL 0501 digital potentiometer, which is controlled by the SPI interface. The analog front end board also comprises of DAC 8830 digital to analog converters, which provides the necessary ramp signals for chirp modulation of the microwave components. Here we have the power supply unit. This is our prototype solution. Here's our product. The PSU is mainly formed by the TPS 5430 buck converter. It is capable of supplying +5, -5 and 12 volts. Here we have the stepper motor driver.
We've chosen the DRV8834 bipolar stepper motor driver since controlling a stepper motor is as simple as pulsing two pins. DRV8834 has undervoltage, overcurrent and temperature protection.
We use the TPS 5430 step-down buck converter to regulate unregulated car voltages. The TPS 5430 offers a simple solution with just 2 resistors, 2 capacitors and 1 inductor. The TPS 5430 also offers us thermal protection and overvoltage protection. We use the LM2662 switch capacitor voltage inverter to provide us -5 volts for the op amps. In total, the power supply unit gives us +5, -5 and +12 volts. From the microwave front end reaches the analog front end board through the SMA connector. The analog front end board consists of TI's OPA 1612 audio op amps, which are ultra low noise and ultra low distortion op amps. We control the gain of these op amps with the TPL 0501 digital potentiometer, which is controlled by the SPI interface from a TIVA C series MCU. We also use the DAC 8830 to provide ramp and chirp inputs to the microwave block. The filtered out output is given out from the audio output port.
Now we'll be demonstrating to you the 6th order anti-aliasing low pass filter at a cutoff frequency of 15 kHz, which is the frequency corresponding to the maximum target velocity. Now we see the frequency response. As you can see, there's an attenuation beyond 15 kHz at a steep roll-off rate of -120 dB per decade.
Frequency of the VCO sweeps according to the ramp chirp generated by the TI DAC DAC 8830 with a reconstruction filter used to remove the carrier to produce pure analog output. DAC 8830 is controlled by TIVA C series program with Energia. You can observe the frequencies peak in the spectrum analyzer. The peak of the VCO output moves from 2.3 to 2.6 GHz and the bandwidth is 300 MHz.
The experimental setup of Doppler effect with microwave components. The apparatus consists of the microwave block, the power supply unit, the analog front end board and the TIVA C series. The microwave block consists of a voltage control oscillator, an attenuator, two low noise amplifiers, a splitter and a mixer. The analog front-end board provides the fixed DC bias level for Doppler experiment. The DAC 8830 is controlled by the TYC series through energy interface. We have the antennas which transmit and receive the signal. This is the antenna, and you can see the antenna feed. As the person with an obstacle moves towards the antennas, there is a change in amplitude and frequency. With a greater relative velocity, the frequency of the beat signal increases, and with the decrease in position, the amplitude swing is higher.